Good afternoon to you. Mark Sudduth, HurricaneTrack.com, here with your Hurricane Outlook and discussion for Friday, July 26, 2019. Things are starting to heat up in the tropics now that we have had the passage of this convectively coupled Kelvin wave, which a lot of people kind of interested in that now. And it's floating around in the weather Twitter, the hurricane blogosphere, as I call it. Basically, the best way that I can describe it in simple layman's terms, a Kelvin wave, this convectively coupled Kelvin wave phenomenon, is kind of like drinking a Red Bull. And it gives you wings, right? It lifts you up. It gives some energy to the tropics. It promotes a generally favorable pattern after its passage that sometimes can reside and sort of get things going for a fairly lengthy amount of time, i.e. more than just a day. You know, it could be something that sets the stage, kind of like another analogy I use, it's like a fertilizer truck going around a field, and after the fertilizer truck passes and it sprays its fertilizer, the field starts to grow. And the same thing with the passage of these convectively coupled Kelvin waves. They come across here in the tropics. And, the processes involved of math, the physics, and other stuff, maybe even metaphysics, is beyond my area of expertise. There are those that can explain it hopefully better. If you really want to dive into the details of it, you can search CCKW or convectively coupled Kelvin waves, also include in that search string Dr. Michael Ventris as an example, and there are others. Bottom line, what it equates to is usually a more favorable pattern in their wake. Different, though related, to the Madden-Julian oscillation, which is a wider spatial phenomenon, covers a larger area of the globe, and that takes longer time for it to pass through, whereas the convectively coupled Kelvin waves move much quicker. Anyhow, what it all means is this. Look, I was kind of not complaining, but pointing out yesterday that Delilah came and went despite the Kelvin wave passage over in this area, and Delilah's gone, and it really didn't amount to anything. Now, we have these other areas, 50%, 70% over the next 2 to 5 days, etc. This one is 10 to 70, so the Hurricane Center is really bullish on these systems developing in the Eastern Pacific. No worries for our friends down here in Mexico or Central America, south and east of the country of Mexico. No worries, as generally strong high pressure in control out here, and that'll be sending these systems generally off to the west with time. But I think you could agree that with the passage of this Kelvin wave, what's left behind is a more favorable environment. The upward motion is starting to change, where we're starting to see more of a rising motion in the atmosphere down here. Because, hey, as I talked about yesterday, I think it was, convection needs rising air, period. Otherwise it's called subsidence, sinking air. And the pattern is starting to change, okay? And we might even see that happening in the Atlantic basin before too long as well. First of all, any interest out near Hawaii, no worries. Nothing coming your way anytime soon. And the Atlantic basin for now is kind of quiet, though I wonder if at the 8 o'clock Eastern time update, this gets updated at 2 p.m. and 8 p.m., 2 a.m. and 8 a.m. from the National Hurricane Center, this outlook. I'm wondering if we see something get hatched, as they call it, out here. Maybe a yellow area. We'll see. Because it looks like something's trying to get going. I'll show you that in a moment, kind of teasing it for now. All right, so here are our disturbances in the Eastern Pacific. And I mean, look, the convectively coupled Kelvin wave moved through here, and now in its wake, the field of tulips is blooming, or whatever, cotton, tobacco, corn, doesn't matter. The fertilizer truck came and went, and now, the plants are blooming along here. I call this a grapevine, and look, there you go. So this is starting to develop. You got this sort of low-level westerly flow coming in that helps to spin up what we call the vorticity with these systems. It's a Red Bull. All right, we should get Red Bull to sponsor these updates. I mean, hey, that'd be cool. They did it for Felix Baumgartner, and his jump. Maybe Red Bull could be a sponsor of this. Somebody from Red Bull Marketing, you know how to find my email. It's on my YouTube profile. Anyhow, seriously, that's the way I think of this. It's literally like you take a Red Bull and boom, you got wings, as they say. The old slogan goes, and look what has happened. This has all come to life, and yes, these systems will get wings, so to speak. They'll sprout and they'll develop and move off to the west-northwest with time, and all of a sudden, the tropics will become a little bit busier here, starting with the eastern Pacific. A little bit of a flare-up here in the Gulf of Mexico, but just looking at the satellite evidence that we can see, look how winds are kind of going this way, blowing across the system. Imagine if you had a candle in your office, your house, your basement, wherever you might be watching this from, your car. Although candles in a car, maybe not a good idea, but you get the idea. You got a candle and it's just burning there, nice and calm, if the airflow is fairly stable. The candle is vertical, the flame. But if you go and blow across it, what happens? Snuff, the candle goes out. Same thing with upward motion in the atmosphere. You need the air to be light, and you notice that all through down here. There are not winds screaming across the tops of these systems. That's not happening. So the air is able to rise, and because of the Coriolis force, you get the turning motion counterclockwise in the northern hemisphere, and there you go. In the Gulf, upper level winds are generally, I'm just guessing here, out of the west to west-southwest, etc., and you're not going to see anything develop because convection cannot blossom under that kind of a pattern. All right, moving into the Atlantic. Wow, it's starting to look different. Here's some energy associated with mid-latitude storminess, the frontal boundary. I'm telling you what, if you could launch a little paper airplane or a balloon way down here, let's say just south of Matamoros in Mexico, and catch the jet stream up through here, these upper level winds, it might make it all the way over to the British Isles. That's pretty amazing, isn't it? And then south of there, check it out. Big time ridging. You can just see the outline of the ridge, generally speaking. I don't know where all the height lines would go or anything like that, but you can really see the meteorological process at work with the westerlies going on up here, and then your easterly trade winds coming down through this area. And what's embedded within those trade winds? Tropical waves, these seedlings of energy. There's another one. I mean, there you go. And where is the convectively coupled Kelvin wave now? I don't know exactly. I didn't look at Dr. Ventress' chart that he sometimes publishes, but I would assume it's passing, and they move pretty quickly. I don't remember how fast, but nevertheless, it's moving across this area, I do believe, and in its wake, what has it done? Despite the overall sinking branch of these cells of pressure, you have rising air, this velocity potential that we talk about, rising air and sinking air around the globe associated with different cells of pressure. You have your Walker cell, your Hadley cell. We're getting into meteorology there, and I don't want to lose you. So again, to boil it down, we've seen Ben Knoll talking about this sinking motion correctly, but inside of that are these little windows of opportunity where sometimes you get these cracks in the armor of the sinking motion, and there you go. These convectively coupled Kelvin waves, these small variabilities in the overall bigger picture, that if most of the Atlantic is dry and the air is sinking, or what we call subsidence in the atmosphere, trying to draw downward motion there, as opposed to upward motion, sometimes you get these little zones where things can try to develop. So I'd have my money on that one right there for the National Hurricane Center to issue an outlook maybe this evening. We'll see. I don't have any inside info. I don't know that they will. They may not. Who knows? But it is something to watch. And obviously, Weather Twitter is keeping an eye on it. This from Eric Webb. And again, folks, this is why I love social media for its good that it can do, because you get this collective following of people who are following collectively people that are smart. And all in all, as long as everybody keeps their cool and you don't get any dingbats, and there are some of those out there, you know that, those notwithstanding, you get some intelligent dialogue going back and forth, and you discover things. And Eric Webb, on top of this, a nice graphic here from the Weather Nerds site, and people chiming in, talking about it. Just amazing. But what did Eric say? Well, let's just take a look at this. This is the image. This is from the Weather Nerds site, weathernerds.org. And you see the low-level flow, which I will superimpose my yellow telestration on top of. Coming along and embedded in that is this nice, sharp wave axis in here. And the tropical wave axis tilted southwest to northeast. There's southwest on this side, right? And then northeast over here. And as Eric was talking about in his tweet, going back to that sometimes when you see this configuration, please work, thank you, that the wave axis being tilted like that the upshear tilted waves like this one are more efficient at converting the background kinetic energy into eddies and are more likely to undergo tropical cyclogenesis. So when you see these fairly sharp, well-defined waves, again, for the layperson, just what's the bottom line, Mark? When you see that, those look to be candidates that are easier to try to develop because they're sharper. They're, they don't have to do as much work to just go ahead and close off and become, instead of the wind coming around and turning a little bit, it goes full circle. They don't have as much work to do. It's easier for them to become a surface low at the surface, of course. And looking at it in the bigger picture, what a great tool this is here from the NRL site in the Naval Research Laboratory. I tracked Hurricane Matthew in 2016 from the time that it was just a blob of energy sitting over Africa until it made its way all the way over past the islands, of course, and all the devastation it brought to Haiti, etc., and into the Carolinas. And it starts right here oftentimes, this strong burst of energy with the standing wave of upward motion over Africa, which has been very dominant. And look at what's happening, convection breaking out now into the Sahara, up here in the northern latitudes, a little bit more so. That will begin to moisten the atmosphere, etc. You know what would make a great movie? By the people, this is a side tangent, so bear with me. A great movie. You've seen that movie that came out, was it last year or the year before? I can't remember. Geostorm. It's by the same minds generally that did The Day After Tomorrow, Independence Day, 2012, wasn't that the name of one of those movies? Those end of the world, popcorn, throw all scientific reasoning out the window, although The Day After Tomorrow is starting to look a little more plausible. Just whatever. Okay. Anyway, right? It's like, I think Roland Emmerich or somebody, the Emmerich family, they work with 20th Century Fox usually, and they put out these big popcorn movies. Well, here's an idea. Now watch, it'll get used and I won't make a dime. If you had a way during hurricane season, or even before, I guess, to wet the Sahara and keep the Saharan air layer at bay, you would destroy the United States economy, probably and other economies, from hurricanes, probably, because you wouldn't have the Saharan air layer, and you can see it right there. There's the outline of it, and I'll show you a better graphic of that in a moment. But for real, this is nature trying to knock it down, but imagine some kind of geoengineering scheme, and that'd make a great movie, because I think right now it's probably too hard to do, but if you could wet the Sahara and keep that dust at bay and make it more humid, on a longer scale, we'd have a lot more hurricanes, everything else being equal. The Atlantic would have to stay warm, you'd have to have instability and all the other things, but kind of a neat little plot idea if anybody out there is into screenwriting and you want a treatment, as they call it, the initial idea of a movie, Merry Christmas, there you go. So, for real though, it's interesting because weird blockbuster movies come from some of these ideas, and weather And here you go. You're seeing these large scales. I mean, think about how wide Africa is, for goodness sake. You know, from the Ethiopian highlands all the way over here to near Dakar in Cape Verde right there, right? Cabo Verde. And in between is all this energy coming with the easterly jet, these impulses of energy that come off, these tropical waves. If they don't develop in the Atlantic, they try to do so in the Pacific. Wow, it's just an incredible phenomenon. No wonder so many people are attached to this. All right, back to my Slither.io reference from yesterday. That is the winning snake right there, as you can clearly see. This is the vorticity signature, and there's that energy. A little bit of an area trying to pinch off here, but probably not going to be able to. More energy down here in the Pacific as those two systems that I talked about earlier try to get going. Look at this energy up here, a little bit more in the way of the vorticity signature showing up, so it's more energized. Some of the modeling saying that this will try to close off into some kind of a mid-latitude system and ride its way in, possibly towards the coast of France. So let's see if it still in the models over the weekend, and I'll show you an animation of that on tomorrow's update, perhaps. Also, in the deep tropics, there's the vorticity signature areas of the tropical waves coming off Africa, etc. So there is more energy out there. It's getting there. There's still a lot of dry air, though, and Saharan air, for sure. And remember I showed you the outline of this a minute. Let's use white. Not black. White, thank you. There we go. Ooh, it shows up much better. I want you to look at something very closely here, all right? People are going to say, oh, yeah, there's tropical waves out there, but there's Saharan dust everywhere. Well, you would be incorrect. There is not Saharan dust everywhere. And where is there not Saharan dust? South of this line, because there's a lot of moisture in here. Otherwise, there'd be sal there and no tropical waves. Partly, this is there, partly because of the passage of the convectively coupled Kelvin wave. One of its, reminder here, benefits to the tropics is it leaves a more moist environment behind. There you go. Check mark, check mark. No sal to speak of. Now that is a pretty good shot of Saharan dust. And if these start to try to develop and grow, and like I said with the old Red Bull slogan, get your wings or gives you wings or whatever it is, there goes my sponsorship because I can't even remember the slogan. But once these start to try to develop, they probably will begin to pull in that Saharan air that's around them. So when people just say willy-nilly, oh, well, it won't develop because of Saharan dust, that's not entirely true. It's not the dust sometimes and the Saharan air that chokes these off. It's that they start to grow and they ingest. Their influence in the atmosphere starts to pull that dust, and, well, not so much the dust as it is the dry air. Notice, too, that the Saharan air layer has made its way over here to the Northeast Caribbean and elsewhere, of course. And by the way, let's just go back real quick to this shot here. Where'd you go? How about my animation? There we are. You guys over here in the windward and leewards, Barbados, Trinidad, Tobago, St. Vincent, the Grenadines, and elsewhere, I would say 15 degrees latitude, which is roughly through here, and south of there, all of this moisture is headed your way. Hopefully some of it can survive and bring you fresh water. Seriously, I know you need the water down there, the fresh water, all right? Just keeping an eye on it for you guys. That could be a big benefit. So, the Saharan air, right, because right now it's like, and I can prove that because, look at this. Our Nest Cam that we have down in St. John at Brent's house. Brent is one of our patrons, one of our supporters, both financially and hands-on, and also for hosting our Nest Cam. Thank you very much. This is today, a short while ago, right before I did the update here, preparing all my material, and the sky is kind of hazy. See that through there? That's the Saharan air layer. You can literally see it. Now you know this. You see it talked about all the time, these aerosol products that get put out by various mapping gurus. I really like the one that Ben Knoll does. The hemispheric shot is really cool. Ryan Maui, who has led the way on a lot of this visualization over the years, and others. I've seen these also filter their way into TV now. Isn't that interesting? What grew from social media and all of us geeking out at looking at it, now it gets used on mainstream television broadcasts and webcasts. Nevertheless, yes, you can see the Saharan air layer in here, and I can prove it because this is what it looked like roughly 24 hours. Oops. Oh, man, I am a dingbat. I'm one of those dingbats. I blew it. I'm not going to restart this, but just skip ahead. All right. So this is today. That's yesterday. So there was some Saharan dust yesterday. Oh, man. I am sorry. And I even was telling myself, remember, this one's first, that one's second. It's okay. I'll shut up and continue on. I screwed up. It's all right. I am not perfect. This is today. This is yesterday. So there was some Saharan dust. You can see the haziness to the sky, to the old sunshine there. But boy, look at today. To prove my point, finally, from my little screw up, here it is today, roughly 24 hours later. What a marked difference. And that, folks, is the Saharan air layer right there. Moving on in, Saharan dust, etc. Even though I messed it up, there's today, there's yesterday. It'll clear out at some point and maybe bring you guys some rain. Brent will be departing and heading up to the lower 48 here next week to help with our testing of our weather balloon over in Elk City in Oklahoma, which is something that we are doing exclusively for our Patreon crowd. So if you've been wondering, should I become a patron? Well, now's a good time because you can be a part of it. No matter what level you sign up at, all of the patrons are going to be able to watch it live. The ground part, we can't stream from the upper atmosphere yet. That'll come. And, they'll get access to a bunch of other cool stuff. But Brent, being one of those patrons, he's helping to make all this happen. And so he's going to have to leave the dusty confines of what he calls the rock and come up to the lower 48 and help us out. All right, so there you go. Some interesting developments. I still wonder, I'll leave you with this. We have seen the demise of the El Nino, the cooling of the Pacific taking place, and the modeling starting to catch up with that. There's this lag, like buffering. Okay, we're all in the internet age. We know what buffering is. All right, so there's this buffer. There's this lag, evidently, that a few months ago, the models, and even a few weeks ago, were all about the El Nino, and some hurricane seasonal forecasts were going on that. So the models are starting to change. I've showed that a little bit. I'll show it even more on Monday when we have a longer discussion that includes a look at anomalies and so forth. But again, I am beginning to wonder, just following logic, and it can be wrong. I mean, I screwed up this and this, so I can screw up my logic sometimes. What if the vertical potential stuff that we've seen Ben talk about, Ben Knoll, Eric Webb, Andy Hazelton, Tyler Stanfield, and others talk about that the models will have to play catch up with that. So once you change the ocean part and the models catch up, the ocean helps to feed the atmosphere. Now the atmosphere part has to catch up. The models catch up to that. Boom, all of a sudden, maybe, and this is what I call keys to the game. Let's see if I'm on to something here or if I'm just wrong. And it's okay. It's okay to be wrong. It's not a forecast. It's something to watch for. All right? And that is, do the models begin to change their tune for more upward motion and favorability in the Atlantic tropics going forward between now and, let's say, the next 2 weeks? Let's see. I'll check in on that on Monday, and I'll show you. And if I'm wrong, I'm wrong. I'll admit it. And again, it's an opinion. It's something to look for. All right, that's it for me for today. We covered a lot. I appreciate you tuning in. If you're not a subscriber already on the YouTube channel, go ahead and do so. It's harmless. It's easy. It's punch the notification bell so that when I post a video, you'll know about it. And that's about it. Have a good weekend. Stay safe out there if you're traveling or on the water, etc. At least you don't have to worry about any hurricane activity for the foreseeable future. Always appreciate you tuning in from whatever device you happen to be watching from and listening. I am Mark Sudduth, HurricaneTrack.com, and I'll have more for you over the weekend ahead.